The following is the video solution from JSDT Solutions. Question 2 says, 2.1, given the quadratic sequence and we have 20, 12, 10, and 14. Okay, we need to determine an expression for the n term of the pattern in the form of Tn equals an squared plus bn plus c. So the first step is we need to find the first differences. So we'll say 12 minus 20, and that is negative 8. And then 10 minus 12 is negative 2. And 14 minus 10 is positive 4. Okay, and then we need to find the second constant difference. So with the second constant difference, you can simply just say, how did you get from negative 8 to negative 2? So you could have said negative 2 minus negative 8, okay, and then add them. But we can also just say we added by 6 to get from negative 8 to negative 2. And then from negative 2 to 4, if this is the second constant difference, it stays consistent. So that's also going to be 6. Okay, we can see that 6 minus 2 is 4. Okay, so this is what we have, and now we equate it to the following. So it means that 2a is equal to 6. And then we say 3a plus b is equal to the first term in the first differences. And then a plus b plus c is equal to the first term in the quadratic. Okay, let's find the value of a first. If 2a is equal to 6, then a is equal to 3. Okay, so a is equal to 3. And then let's find b. So we'll say 3 times 3 plus b is equal to negative 8. And then b is equal to negative 8, and this becomes 9. So if you transpose 9, becomes minus 9. So that is negative 17. And then c, we'll find c by saying a plus b plus c equals 20. But we already know what a is. A is 3, and then b is negative 17, and then plus c equals 20. So 3 minus 17 is negative 14. So we're saying positive c is equal to 20, and we can transpose that negative 14, so it becomes positive 14, and we have positive 34. So this means in the form of an squared plus bn plus c that tn is equal to 3n squared minus 17n plus 34. And that is our answer. Moving on to the next question. Question 2.1.2 says, the first differences form an arithmetic sequence as usual. Okay, this is an arithmetic sequence that we'll have there. And they want us to determine between which successive terms in the quadratic sequence the first difference will be 148. Okay, so looking at these, right, we're saying between which two terms in this quadratic pattern will we have a first difference of 147. Okay, so these continue. Look at the first differences. They want to find out between which two terms in the quadratic will there be a first difference of 148. 148, not 147. Well, we can easily find this because this is a pattern with more than one term that we have, okay? So we can find its formula, and then we can find out which term number belongs to 148 in this first difference. So, for example, this is term 1, term 2, term 3. So let's just find out which term number that would be. It's an arithmetic pattern, okay? That's an arithmetic pattern, the first differences. So it's going to be in the form of a plus, and the value of a here, the first term, is negative 8. So it's negative 8 plus n minus 1 multiplied by the difference, which we can see is 6. So we're just trying to find out which term exactly is 148. 148 is equal to, so in place of tn, that's what we put, and we're trying to find the term number. Okay, so negative 8 plus n minus 1 times 6. If we transpose that, it becomes positive. So that's 140 plus 16, which is 156, is equal to, and we have 6 times n minus 1. And then we can just divide both hand sides by 6. And 156 divided by 6 is 26. So we'll say that if you divide both hand sides by 6, we get 26 is equal to n minus 1. And transpose the 1, it's now plus 1. So n is equal to 27. So in the first differences, term 27 has a value of 148. So we found out what term number this is. If this is term 27, between which two terms would this lie? Okay, it will lie between term 27 and term 28. Because do you see that your quadratic pattern will always have one term more than the arithmetic pattern, the first differences. Okay, just like here we have term 1 between term 1 and term 2 in the quadratic pattern. Term 2 is between term 2 and term 3 in the quadratic pattern. So term 27 would be between term 27 and term 28. So we need to just conclude that and tell them it's going to be between term 27 and 28. Okay, and that is our answer. Moving on to the next question. Question 2.1.3 says, determine the smallest value of n for which Sn, the sum of n terms, okay, is greater than 10,140. Okay, so the sum of n terms. It's just an inequality in this case. So let's find out what the sum of n terms would be. Okay, that formula. So we're working with an arithmetic pattern. We don't know what the last term is, of course, because we don't know how many terms there are. But what we can just use is this formula. So Sn equals n over 2 and then multiply by 2a plus n minus 1 times d. And we have the value of d, we have the value of a. So we can say Sn is equal to n over 2 multiplied by, and this is 2 multiplied by the a value, the first term in the arithmetic pattern is negative 8, and then plus n minus 1 multiplied by the constant difference, which was positive 6. Okay, so what we're just trying to find out is for which values of n, what is the smallest value of n for which Sn is greater than 10,140. So we'll just substitute this here and then solve for this inequality. Okay, let's start simplifying. So this is n over 2, and then these multiply to give us negative 16. And if we distribute the 6 there, that is minus, let's just start with the negative. Negative 6 and then positive 6n is greater than 10,140. Okay, and we can simplify what is inside first. N over 2, and then we have 6n, and those give us negative 22. Okay, which is greater than 10,140. And you see that we're going to have to distribute. This is a quadratic equation that we'll have. So let's just transpose this since this side is already not equal to 0. So we have distribute this here. If you say n over 2 times 6n, then because we have 2 in common, we have 3n squared. So 3n squared, and then that multiplies and becomes negative. You see the 2 is going to cancel. 22 divided by 2 is 11. So this is negative 11n. And then transpose this. This is negative 10,140. And this is greater than 0. And we need to factorize this. Okay, so to quickly factorize this, I will still factorize, but I'm actually just going to do this in a quick method. So it's not really factorizing. It's using the quadratic formula, but I'm just going to use the factors that we get from it. So if we put in the quadratic formula, x equals negative b. So negative b, and b is negative 11. So it's minus 11 plus minus, I'll start with the plus, b squared minus 4ac. So that's negative 11 squared. We could have just said 11 squared. Minus 4 times a, which is 3. And then c, which is negative 10,140. And this goes all over to a, which is 3. Okay, so do you see that one of the factors, one of the solutions is 60. So n is equal to 60. And so what it means about the factor, let's just put that one here. What it means about the factor is that the factor was n minus 60 if you transpose the 60. Okay, so that's how we got n is equal to 60. And then let's find the other factor. So just change that to a minus, and it's a fraction, but you can just put it back as a fraction. So if this answer is n equals negative 169 over 3, then it means that your factor was simply transpose that. That will be n plus 169 over 3. And then it means that this 3 was in front of the n. So it was 3n plus 169. And that's how you set is equal to 0. You transposed it and divided both hand sides by 3 to get back to that. So it's 3n plus 169. So these are our factors, and we already have our solutions now, and we can answer. Okay, so these are not necessarily solutions. I call them solutions. They're critical values because this is an inequality. Okay, so since these are critical values, but you see that this is a negative and it's a fractional number, so we can't take this because these are patterns. You can't have term -2, okay, or term -1/2, or term 3/2. There's no such thing. Terms represent positions. So the one we'll go with is where n is equal to 60. So let's just see. We still need to solve for the inequality. So it was a quadratic equation, right, expression that we had there. But you see that this is a parabola, and it's specifically a concave up parabola. Okay, if it's a concave up parabola and the critical values were -169/3, we won't really consider that one. And the 60, this was just asking us to solve for n where the function is greater than 0. Now remember from the first questions that if the function is greater than 0, we're just referring to the y values of this graph. The y values are greater than 0 where the graph is above the x-axis, and it's less than 0 where it's below. So we're only going to look at parts of the graph that lie above the x-axis. So that's over here, and that's over here. You don't have to really consider this one so much because we're not even going to work with that critical value. So do you see that if you line this part down to the x-axis, you see that these are values that are greater than 60. So we can simply say n is greater than 60. This would be the answer to our inequality. Now let's go back to what the question is specifically asking for. They said determine the smallest value of n for which Sn is greater than, okay, 10,140. We found out that the values of n for which this works is where n is greater than 60. Think about the numbers that this refers to. Values greater than 60 are numbers like 61, 62, 63, and all values greater than 60. They want the smallest value of n. Remember that n refers to term values. They can't be fractions, okay? So it means that our answer for n will have to take the smallest value within this range, okay? It's not 60 because n is greater than 60, not equal to 60. Therefore, n is equal to 61. That would be the smallest value in this range, in these answers, values greater than 60. Okay, and that is our answer. Moving on to the next question. Question 2.2 says, if we have the sum of a series r plus b, right, starting at r equals 1 and ending at r equals 5, and the sum of that series is equal to 10a, we need to determine b in terms of a. Okay, so let's expand. Now, honestly, with expanding, I just need two things from this. This is an arithmetic pattern, okay, because you're just saying r plus b. Say when r is equal to 1, that's 1 plus b. When r is equal to 2, that's 2 plus b. So it's arithmetic. We just keep adding by 1. Okay, so we add 1 to the previous term. So to find the sum of this series, because it's arithmetic, I'll just use this formula, n over 2, okay, times a plus l. And so from this, you see that all we need is the value of n. How many terms are there? We need the value of a, and we need the value of l. So I'm just going to focus on finding those. Okay, so the value of n is, we'll just say n is equal to, and this is the number of terms. To find out how many terms there are here, you're starting at r equals 1 and ending at 5. So it means there are a total of 5 terms. You can also just say 5 minus 1 plus 1, which is 5. Okay, so 5 terms we have. And what is a? A is the first term. So it's a result of substituting this value, okay, that we start at. So that is r plus b, which is 1 plus b. I'll just call it b plus 1, okay? And then the last term it ends at r equals 5. So substitute 5 in place of r. And so L is equal to, that's 5 plus B. And then we can just say B plus 5. So there we go. These are all we need. And we can find, this is all we need. So we'll say S of 5 terms, sum of 5 terms is equal to 5 over 2 multiplied by B plus 1 plus B plus 5. And we know what the sum of these 5 terms give us. They give us 10a. So 10a is equal to, and just simplify. So this is now 2b, and that's plus 6. Okay, I just want to simplify this in the, in a way that I don't have to complicate things. So let's get rid of this 5 over 2. And we can do that by multiplying both hand sides by 2 over 5. So times 2 over 5, it's the same thing as dividing both hand sides by 5 over 2. So this now becomes, you see that 10a is in the numerator. So 10 and 5 have 5 in common. So divided by 5 is 2. So that's 2 times 2a, which is 4a, is equal to, and this cancels, and we have 2b plus 6. Okay, this is our equation. And we simply have to determine b in terms of a. So solve for b, and it will be in terms of a. So you can transpose 6. So we have 4a minus 6 is equal to 2b, and divide both hand sides of this equation by 2. Therefore, b is equal to 4a divided by 2 is 2a, and negative 6 divided by 2 is negative 3. And there we go. This is b in terms of a. And that is our answer. And that is it for question 2.